Okay, so following on from the Michaelis Menten graph, we're going to cover the Lineweaver-Burk model. So we're going to do what the graph looks like and what it tells us and how we can calculate Km and Vmax. Now the Lineweaver-Burk is essentially a linear transformation of the Michaelis Menten model. And if you remember, we looked at that in the last video. I'll pop a little link in the top right. So if we look at the shape, it's actually a straight line, which is the transformation of Michaelis Menten. And it shows us the rate and the enzyme activity as well. We can also use it to calculate the Km and the Vmax using different points on the graph, which you will see very, very soon. And also, we can see that it shows different enzyme inhibitors and how that affects the shape of the graph, and how it also affects Km and Vmax, which we will see in another video, but not today. So let's move on now and draw the graph. So you can see I'm drawing the axes here, and of course this does have a negative part of the graph, as you can see on the left, and we're going to have different axes this time. We're going to have 1 over v on the y-axis and 1 over s on the x-axis. And we can call this straight line here the real results, and these intersect the y-axis, and we can call this point the 1 over Vmax, and where it intersects the x-axis, we can call that the negative 1 over Km. As you can see, I'm just putting these on here. So you can put the example of 5 and negative 10. I know it's not quite scale, but we're going to use these numbers for today. And like I mentioned, this is 1 over Vmax. I did miss off the 1, but this is 1 over Vmax. And this here, of course, should be also negative 1 over Km, which I did make the mistake of. So now that we've got those labelled, we can go ahead and say that it's useful for calculations. I'm going to do a few calculations for examples here now. So we can start with the Vmax. We can say that 1 over Vmax is equal to 5 using the y-intercept. And because we have 1 over Vmax equal to 5, we can say that this is 1 over 5 when rearranged, and this makes 0.2. Now let's go to Km. So we can say that negative 1, there we go, there's the correction, negative 1 over Km is going to be negative 10. So let's just correct this properly. Negative 1 over Km, and negative 1 over Km is equal to negative 10. So if we go ahead and do the maths and rearrange this, we can say that Km is equal to negative 1 over negative 10, which of course is 0.1. So now we can also say a few more things. We can say that the lower the Km we have a stronger affinity between the enzyme and the substrate. And if you remember from before, in the last video, the affinity is that strength of bonding between the enzyme and the substrate. And a higher Vmax simply means that we have a higher maximum velocity. So this usually indicates a more efficient, more powerful catalyst. So hopefully that makes the Lineweaver-Burk super simple to understand, and I hope you enjoy. Thank you.